looking for a system which in 95% or ideally 99% plus cases is going to suit me, protect myself, protect everybody in the room, and be a very viable solution.
Do you think there's a threshold of radiation reduction as compared to a co-control that is a goal for you? I mean, right now we're seeing radiation protections in the 90s, 90% ranges and or more. And is that adequate? I know you said you want to get to 100, but would that satisfy you in terms of your ability to use an alternative lead solution?
Yeah, I mean, I think it would.
Yeah.
If we could have more than 90% radiation protection in the majority of our cases, and I'm not a physicist, and I maybe have to sit down with my physicist, but hey, can I now decrease my lead?
Right.
Can I use a thinner lead? If I'm going to be far away, can I, maybe just have a shield in front of me, for our nurses and so forth?
Or if you're hugging the II, is that, I'm getting the same degree of protection as if I'm standing at the side of the table. Yeah. That's a big deal. There aren't many systems that can do that.
I mean, looking for a system. That's what we're looking for.
Right.
I want good radiation protection. I want to be able to be very versatile, pretty much do any type of procedure without having any issues. And at the end of the day, if we could have that, and something that's dynamic, it doesn't really change our workflow, something that's easy to set up.
Yeah.
Then that's going to be kind of a perfect solution.
Agreed. So we're going to go into the radiation system, and I'm going to take a little time here to walk through the kind of difference between this system and the existing other systems. The other systems are really enhanced barrier systems in terms of the shielding that's surrounding the table. They can be heavy, they can be effective, but they have some limitations about getting to the patient in emergencies and having issues around prep and draping and all the other things. And so the radiation system, I think, addresses a lot of those and is a much more flexible system. The reason for that is it blocks the scatter radiation at the source of the radiation. So we're not waiting for the radiation to emanate from the scatter. We're taking care of it at the time it's generated. And that allows for 90% or more protection and an ability to wear light lead. Interestingly, because it's attached to the imaging system, the FDA classifies it as a Class II device. And that may sound like a burden, but in point of fact for us as kind of consumers of this technology, the scatter protection, the other therapies haven't been put to the same standard. So radiation will actually have a set of data at a FDA quality metric that will allow us to really understand what we're getting, not just hearsay, not just anything else, but at a standard the FDA sets. And that's a big deal. As we talked about before, there's no real blocking of the patient. We'll show you a video of the device in a minute, but you can see that it lifts up out of the way in a second or two. And so you can immediately get to the patient during an emergency without any real delay.
I think that's really key.
It's huge. It's huge.
Like you mentioned with anesthesia, a lot of the things that we're doing, all of a sudden something bad happens, you got to get in there.
Absolutely. And then it does allow for a lot of flexibility and protects everybody in the room. So it's not just the people at the side of the bed, but everybody in the room is protected because the shield comes down, again, at the source of the scatter, not waiting for the scatter to emanate and then trying to catch it. And so it allows you steep angulations, it allows access to different types of procedures, and it has easy setup and rapid turnover. We've installed it in a couple different labs around the country. One of the labs is incredibly busy, crazy busy, and has not seen any slowdown in their productivity.
I think that's so critical.
Yeah.
I mean, we've been through a lot of different kind of iterations in our lab with new technologies, and any type of technology that's going to slow you down, that requires a lot of prep, it's hard to integrate.
Well, it's hard to get physicians to use it.
Yeah, 100%.
I mean, they're going to be reluctant anyway, but I think, the easier, it's axiomatic in medicine, procedural medicine, the easier it is, the more we do it.
Yeah, absolutely.
Yeah. All right, so let's look at this video. This is a video now of the radiation device. It's attached to the II and below to the generator. And you can see here that there's multiple different fingers that come down onto the patient and then flaps that complete the kind of radiation scatter shielding that allows you these steep angles quick setup in terms of radiation protection. So you can move from angle to angle to angle, which is probably not as relevant for IR as it is for cardiology, because we do a lot of multi-angle procedures. I don't know, I may be overstating that, but we do a lot of multi-angle procedures, and I sometimes have to go to steep LAO RAO angles to get to where I need to be, even lateral angles, and this really allows that flexibility. Whereas a lot of the other ones, I probably would get blocked. I wouldn't be able to see through some of the shielding that's existing there.
Yeah, a lot of the non-vascular procedures we do, require all kinds of crazy angles.
Oh, there you go. Yeah.
Biliary interventions, for example. We're starting doing endo-leak interventions where, you might be in a really strange angle. So, yes, and as we all know, the more you angle the tube, you're increasing the radiation exposure exponentially.
Right.
But what I just saw and what I witnessed here is that you're protecting the patient even at these very oblique angles, which is extremely, extremely, favorable in my opinion.
I think it's incredibly valuable, and one of the real assets of this technology. Those lowering shields are made of a tungsten material. It's not lead, so it's not really heavy. It allows that kind of mobility, and there are 3 levels of safety for the patient, which talk about proximity and contact sensors, so that the patient doesn't get inundated with the device. And then there's a really nice feature of the device that allows you to pan the table. It's called hover mode, so that it will lift up just a little bit, so it has a little space for you to hover, and you can drop it back down again. So you can fluoro while you're moving if you need to, with a lot of radiation protection. Then you drop it again for the full
I like that versatility. Yeah, but there's going to be times when you want to move things a little bit to get where you want to be, and then initiate the radiation.
We do this all the time. We pan down the leg to make sure that we have the full run of the table, right? And
Absolutely.
we don't want to lose radiation protection during that maneuver. So it's a big deal.
Yeah, absolutely.
Yeah.